The second sample problem we have for week 1 involves integrated rate laws. Now the integrated rate laws require you to do a little bit of special math as well. So if it's been a while since you've done any arithmetic involving natural logs, again, make sure you download this file from D2L called Algebra Review and refresh your memory on how to solve any sort of algebraic expression involving a natural log. So this information will be provided to you. You're not going to be required to memorize the integrated rate laws for first order and second order. All you need to be able to do is pick the right one and use it appropriately. And then the integrated rate laws for zero order are right here. Okay, so these will be given to you on your next test. You can have a reference page that I will post online for you to use. All right, so here's our sample problem. Now I'm telling you it's first order, and I'm telling you that the rate constant is 6.93 times 10 to the negative third seconds inverse. And I'm telling you that the initial concentration of N2O5 is 0.1 molar, and I want to know how much of N2O5 do I have left after 150 seconds have gone by. So since this is a first order reaction, I'm going to pick a first order integrated rate law. All right, now remember, this little 0 means initial, right? So this is my initial concentration right there. So I'm just going to do some math now. I want to know what this value is. That's what I'm solving for. So you can let this be x for all I care, right? Because all we're doing is solving for this value. So negative k, so take this, dump it in, right? This negative is part of the formula. T, right here. Now make sure your units of time match, okay? If time is given to you in hours and k is given to you in seconds inverse, make sure you convert seconds to hours or hours to seconds, okay? Because the unit of time does need to match, otherwise your arithmetic will be way off. All right, so I'm just plugging in. There's my k, there's my time, and the natural log of 0.1, because I told you the initial concentration is 0.1. Okay, so this times this gives me this. Natural log of 0.1 is this. So when you add those two together, we get this. So how do we get rid of a natural log? We take both sides, we raise it to the e. So if you just want to call this x, so natural log of x equals negative 3.343. To get rid of that natural log, you'd say e to the natural log of x is equal to e to the negative 3.343. So in your calculator, you should have a button that says e to the x, or some button similar to that. And so when you enter e to the negative 3.343 in your calculator, you get 0.0353 moles per liter. And then ask yourself, is my answer reasonable? You would expect the concentration to go down over time, right? And it does, because you started with 0.1, you end with 0.03. So yes, your answer is reasonable. If somehow you get an answer that's higher than what you started at, you know you made a mistake in your math. And that's the end of this sample problem.